Welcome back. In this week, we are going to do a further demonstration from where we left in week 1. So before we go anywhere, like I said, we are going to create another package for week 2. So I'm going back to the same project that I created previously, Java demo, and then I go to source packages, and here on source packages, I'm going to create a Java package and name it week 2. Now, in this package, I'm going to create a class. I'm going to create a class here. So this is, I'm going to create a Java class. And then let me just name it demo as well. Name it demo. It's a Java class. It's not a Java main class. So basically, the things that we want to look at as follows in this one. We want to look at lexical issues. Particularly, we want to look at the white space. Then we want to look at access and non-access modifiers. These are things that we want to basically look at. Okay. Now, in this one, let me start by creating a variable. Let me say string name, and then let me create another one. Let me say float height, and just these two. Okay. Now let me have a method here. I'll call this method void details. Get details. And in this get details, okay, since we haven't done how to accept numbers from users, so let me not use get details. Let me just use show details. Show details. And here I'm going to initialize these ones. Let's say name 2. Let's say maybe 1.6. Just wait for it to respond. Okay, 1.6 like this. Now, the reason why 1.6, this statement is giving us errors is because Java by default takes all numbers with a floating point to be decimals. So we are trying to convert it. So it takes all numbers with floating points to be double. So we are trying to convert a double and store it in a float. So what you just need to do is to suffix with F to tell the compiler that this is a float that we're talking about here. All right. Now here, I'm just going to show output or the quantities or the values stored in those variables. All right. So let me, I'm going to say name is, all right. So this is going to be displayed as it is, and then plus name. So the name that I've written here is the name that is here. So this is going to be read from the variable. This is going to be displayed as is. And then here, let me do the same, copy paste, edit here and say height is. Now we are going to get the height from the variable height. Like we did last time, I can come, I'm going to create a Java main class. So I'm going to right click there, go to Java main class, and let me call this Java main class driver as well. Call it driver. And in this main class, I'm going to create an object of demo. So I'll create an object of demo. D, that's a variable, then the object we are creating it here and it's being stored in D. Now I go on and type D dot show details. If I run this one, we will see that it will show us the details, which is the name. Name is equal to height is 1.6. There's nothing new there. It's the same as what we did in the previous video. Now we want to apply the concept of access modifiers. To start with, right now we have variables here. These ones, string name, float height, right? These variables, they don't have any access modifiers specified. So they have what is known as default level, default package level access modifier. It's called default package level access modifier, which means that these variables can be accessed by any class within the same package, which means we can access name and height from a different class. Like in this case, if we come to driver, I can come here and type, instead of, I can come here and type, say, system ln. So remember, we've created an object here, d, so I can say d dot height. See d dot height. This one will access what the height that is in the class demo. Okay. So if I run this one, we expect it to show the height twice. Let's see. You see 1.6. This 1.6 is being displayed because of this statement that I have here. So any class that is within the same package as this class demo can access the attributes of demo. Now, it is not allowed, or it is not recommended to make variables, to make them accessible to other classes that can modify their numbers or their values. Like here, I can come here and type, say, d dot height, and say maybe 8, like this one. This has modified the height, and now the height is being modified in another class. So you will see that when we display the height here, it will be 1.6, but when we display it after this statement here, it's going to be 8. So this is not, most of the time, it's not allowed. See, this was 1.6, and this is now 8 because we modified it here. So most of the times, it is encouraged that we make variables private. So I can come here and write private. The moment I write private here, it means this is no longer accessible to other classes. I can come here and write private. It also means that this is no longer accessible to other classes. And you can see that there are now errors here, because here we are trying to access height in a different class, yet height is private. So private means the variable can only be accessed within that same class. These variables can only be accessed within this class. They cannot be accessed outside of this class. Okay. So these two statements no longer work. So that's how private works. Private is an access modifier that makes a piece of code, whether a class or a variable or a method, only accessible within the same class. Now, we also have other access modifiers like public. This one, this show details, we are able to access it within this other class because they are within the same package. However, let's suppose we wanted to access this method show details from another class which is in another package, like say in this driver which is in week 1. In that case, we cannot be able to access show details because show details is not public. We need to make show details public so that we can be able to access it from a different package. All right. So this is what we do. We have our class here demo. So we can come here and write, we can come here and write demo. So maybe demo DE. Like this. This is giving us an error because the class demo is in a different package. So if you want to access demo, we need to import this package week 2 first. So you can just click here, it will show you, okay, you need to import week2.demo So I'm going to simply click here. So we have imported week2.demo, which means we have imported in week2 package, we have imported a class called demo. Now we are able to access it. Okay. We are now able to access our class. The reason why we are able to access our class here is because this class demo is public. However, the method show details is not public. So if we come here and try to write de.show details like this one, this is going to give us an error. And if you look at the error, it says show details is not public in demo, cannot be accessed from outside package. So for this error to go, we need to use another access modifier here. When we come to show demo, we just have to make this method public. If you come back here, the error should disappear. If the error, it has disappeared. You can simply save and see if the error will go. So the error has now disappeared, which means these messages that we're seeing, like name is equal to height is 1.6, we can now see them even after running this file. So we can do this, and there we are, those details which are being shown here. So those are some of the access modifiers. We have looked at private, we have looked at public. Now, let's look at protected. If we want to look at protected, for instance, I can come here and say maybe have protected void my details. Now, if we use protected, it's the concept, the difference between protected and public is that with protected, it can be accessed by all classes within the same package, as well as the child classes of demo. So this show details, we can still access it from this class. Here I can come and say or what's the name of this one? My details. Okay. I can come here and type d.my details like that one. There is no error because it's within the same package. So protected methods are also accessible within the same package. They can also be accessed by other classes which are in different packages, as long as they are subclasses of the class demo. So that's how protected works. So we've looked at default, we've looked at protected, we've looked at public as well as private. So those are the access modifiers. Now we also have what are known as non-access modifiers. For the non-access modifiers, we have, for the non-access modifiers, we have static. We're going to look at static. We are going to look at final. Those are the access modifiers we are going to look at. If we say static, it means it's a class variable. If you say final, it means it's a constant. So for instance, let's say maybe we want a method that will calculate someone's age. We can have final, we can have a final variable, like say, can say final, because it's a constant, constants are written in uppercase. So you can say final int, let me say final int current year. This one will be 2021. Right. That's the current year, and this is a constant. Right. So if you with constants, this is how we create constants. Once you mark a variable as final, you also need to initialize it and then name the variable or the identifier in uppercase. So this is a non-constant. I mean, this is a constant. You can access this value anywhere. This constant can be static. It can also be non-static. So you can type static final int current year. The order of static and final is not important. You can interchange final and static. It still doesn't give a problem. However, you cannot interchange the data type. The data type must always precede the identifier. So you cannot take int, like you cannot take this int and put it elsewhere, like here. You cannot do that. So that's one of the non-access modifiers. And then we have also included the static access modifier there. Okay. So a static member of a class, it is a member that can be accessed via the class name instead of the object. For instance, let me first of all remove final like this. If you come back to driver, you can come here and write system out. Then we want to display final. So I'm going to say d dot current static. Okay, so I want to make it final. D dot current year is final, and we can access it here. I can run here and it will show us 2021 because of this statement that I've written here. It's final, but it's not static. So because it's not static, it's an instance variable. We can access it through an instance. Remember, D is a variable that is pointing to our new instance or our new object. So we have to access this one through the object since it's not a static variable. However, if you come back here and mark this one as static, that changes it from an instance variable to a class variable. So when you come back here, this now is giving us a warning that we are accessing a static field current here, and then we are accessing it using an object. So for a static field, we don't use an object. We actually use the name of the class. Remember, the name of the class in which this current here is declared, it's demo. So when we come here, instead of using an object, we write the name of the class as demo dot then the variable, and that warning disappears. So that's the difference between these two non-access modifiers, static and final. So I think that should basically clear things out as far as those ones are concerned. Maybe let's now look at the white space, like how is the white space handled? All right. Let's suppose we have this variable, this method, my details. I'm just going to use my details to show an example of how the white space is treated. Suppose here I'm declaring a variable int a, and I want a to store 3 plus 6, like this one. You see, int a 4, then we have plus on the next line, then we have 6 on the next line. Java is not even complaining here. It doesn't care about the white spaces. It knows that this statement is not ended until we put a semicolon, which is a terminator. Okay? So that's how white space response. It's just ignored. Right? There are no issues there. You can do this depending on whatever you want when you're writing your own project. So that's how white space is handled. Okay. So I think in short, I'm trying to make the videos shorter. So I think in short, that's all we needed to look at for this week. Unless there are any issues, you can bring them to my attention. But as for now, I think we can call it a day. Thank you.